All right, lesson 17. Let's talk about probability. Probability of an event is the likelihood that something will occur. If an event will never occur, the probability is 0. If an event will always occur, the probability is 1. All other probabilities fall between those two numbers, 0 and 1. All of the numbers falling between those, 0 and 1. Use the fractions to write the probability of an event. So the probability of an event is the number of favorable outcomes, the things you want, over the number of possible outcomes. So think of rolling a fair die. So a die is a single dice. So if you have 2 dice, a 6-sided dice, then like when you're playing Monopoly or a board game, if you have 2, it's dice. If you have 1, it's die. So if you're rolling a fair die, what's probably rolling a 3? All right, well, you only have 6 choices, 1 through 6. So the probability of rolling a dice, rolling a 3 is 1 over 6. All right. The probability of rolling an even number, well, that's 2, 4, or 6. So that would be 3 over 6, which is 1/2. You always reduce if you can. Probability of rolling a 7. Well, 1 out of 6 doesn't include a 7, so the probability of getting that is 0. What about a number less than 10? Well, 1 through 6 are your choices. They're all less than 10, so my answer is 1. It's always going to occur. All right? In a jar, there are 3 blue marbles and 5 red marbles. If you reach into a jar and pick out a marble without looking, what is the probability that you'll pick out a blue marble? So you have a total of 8 marbles, and the chances of you picking out a blue one are 3 out of 8. All right? So there you go. There's nothing to reduce, so that's your answer. Now, what is the probability of choosing? What is the probability of choosing without looking at a red face card from a deck, a regular deck of cards? A face card is a jack, a queen, or a king. All right, so without looking, first of all, in Canvas, there's going to be a breakdown of an entire card deck, and it will be available on your final exam. There's also a breakdown of 2 dice rolled out, all the different possible combinations, all 36 of them. That will also be on your final exam. All right, so you can refer back to Canvas as you work through this if you need to. But there are 4 suits, 13 cards in each suit. There are 2 red, 2 black. Okay, so the chances of you picking a red face card, a jack, a queen, or king, if there's 3 choices and 2 suits that are red, that's 6 choices total out of 52 cards. So 6 out of 52, and you reduce that, and you get 3 over 26, and that would be your answer. So you have 3 out of 26 chances of rolling or picking a red face card. All right, what about a fair penny? You have heads or tails. What's the probability of rolling a heads or rolling a tails? 1 and 2, so 1/2. Same thing for rolling heads or flipping heads, so 1 and 2. What's the probability of flipping a head or a tail? Well, that's your only 2 choices, so chances are pretty good. 1. You flip the penny 10 times, you get 10 heads. What is the probability of getting 10? What is the probability of getting a head on the next flip? Well, the chances of you getting, you only have 2 choices, and no matter how far you go in flipping, the chances are always 1 and 2. So it doesn't change no matter how many times you flip it. You always get 1 and 2. Even if you have a string of heads like this or a string of tails, overall, the more you flip it, the chances are always 1 and 2. Okay, you have 6 same-size balls, numbered 1, 2, 4, 5, 7, and 8 in a box. You pick up 1 without looking. What is the probability of picking an 8? Well, 1, 2, 3, 4, 5, 6 options. 6 balls, so you have the chances of getting an 8 are 1 in 6. An even number, see we got 2, 4, and 8, so that would be 3 over 6, or 3 out of 6, which reduces to 1 and 2. All right, number greater than 6, well, 7 and 8 are in there. That's 2 choices out of 6, so that's 2 out of 6, which is 1/3. 1 in 3 chances. A number divisible by 6, so none of these numbers are divisible by 6, so the chances of getting that are 0. The chances of getting that are 0. A multiple of 4. Well, 4 and 8 are multiples of 4, so that's 2 and 6, which reduces to 1/3. or 1 in 3. Okay, let's keep going. You have a standard deck of 52 cards. What's the probability of picking a 7? Well, there's 4 7s, so 4 out of 52. That's going to be 1 in 13 when you reduce. A red card. Well, half of them are red, so that is 26 out of 52, which again reduces to 1/2, or 1 in 2. A heart. There's 4 suits: diamonds, hearts, clubs, and spades. Okay, a heart that's going to be 13 out of 52, which reduces to 1/4. You could have gone, there's 4 suits, you could have gone straight to the 1/4 if you wanted to. A non-face card. Earlier in a previous problem, we said a face card was a jack, king, or queen. There are 3 of those. There's 4 suits. That's 12 total. So 52 minus 12 is 40. So 40 out of 52. And that's going to reduce to 10 over 13. So 10 out of 13 chances that you're going to get a non-face card. A 2, 3, or 4. So 2, 3, 4, there's 4 of each one. So that is 3 times 4 is 12. So you get 12 out of 52. And that's going to give you 3 over 13, or 3 out of 13 when you reduce. A 9 or a 10. All right, well, there's 2 of those. A 9 or a 10. What about a 9 or 10? Well, there's 2 of those. 2 times 4 is 8, so 8 out of 52. And that's going to reduce to 2 out of 13. A jack or a queen or a king. Earlier we said a red face card. Now we're asking for all face cards. So there are 3 of them. 4 times 3 is 12. So 12 out of 52 is going to be 3 over 13. Okay. All right. A golf bag contains 2 red tees, 4 blue tees, and 5 white tees. What is the probability of drawing a red tee? Well, 2, 4, and 5, that's 11. So the chances of you getting a red is 2 out of 11. All right, what's the probability of drawing a tee drawn random is not red? Well, if it always works, the probability is 1. And if the chances of drawing a red is 2 out of 11, you can simply say 1 minus 2 elevenths, which would give you 9 out of 11. Or you can simply say, well, I got 4 blue, 5 red, that's 9. Those are not red, so 9 out of 11. The 1 minus, so if drawing a red is 2 out of 11, then I can say 1 minus 2 out of 11 to get the others. That process is called using the complement. So if red is 2, drawing a red is 2 out of 11, the complement would be 1 minus that. So 9 11ths. Okay, so last one on this page. What is the probability of the event that a tee drawn at random is either red or blue? All right, so red is, the chances of drawing a red are 2 out of 11. And the chances of drawing a blue are 4 out of 11. And I'll add those up, and I'll get 6 over 11. Okay. All right. So this is the version of what's in Canvas. This is just a simplified version. This gives you the probability of, if you have 2 dice, if you have a pair of dice and you roll, what's the chances of the sum of 2 showing up, the chances of 3 showing up, 4 showing up. And so there's 36 total outcomes, and this gives you the probability of each of those showing up. So a pair of dice is rolled, find the probability of rolling each of the following events. Rolling at double 6s. Well, double 6s is 12, so that only happens once. As you can see here. You only get 12 one time out of 36. So that would be 1 in 36. What are the chances of rolling the sum of 7 or 11? Well, the sum of 7 is 6 over 36, and the sum of 11 shows up 2 out of 36. So you have 6 out of 36 plus 2 out of 36, which is 8 out of 36. So that's going to give you, 4 goes into both of those, it's going to be 2 over 9. Okay, so there's that. Using the same chart, a pair of fair dice are rolled. Find the probability of rolling a sum that is even or prime. Okay, so even, you got, it's going to be kind of lengthy, but you got 2 is 1 in 36, 4 is 3 in 36, 6 is 5 out of 36, 2, 4, 6, 8 is 5 out of 36, 10 is 3 out of 36, 12 is 1 out of 36. Prime, we don't want any overlaps. So prime is going to be 5, 2, 3, 5, 7, 11. We've already included the 2, so we don't need it again. 3 would be 2 out of 36. 5 would be 4 out of 36. 7 would be 6 out of 36. And 11 would be 2 out of 36. We would add all these up. So once again, this is 2, 4, 6, 8. The chances of 2, 4, 6, 8, 10, 12 showing up. We've already got the 2, so we don't need the 2 in the prime numbers, but this would be 3, 5, 7, 11. What are the chances of all of these showing up? We add them all up, and you get 32 out of 36. And that reduces, so 8 over 9. So 8 over 9 would be the chances of you getting any of those. What's the probability of rolling a 6 on a fair die if we know that the roll is an even number? Okay, well, your only choices, remember this is a fair die, not dice, so this is only 1. The only even numbers on a fair die are 2, 4, and 6. So if you roll an even number, the chances of it being a 6 are 1 in 3. So 1/3. Number 11, if you are dealt 2 cards successively without replacement from a standard 52 card deck, find the probability of getting 2 black cards. Okay, so this one's different because we pull 1 card. When we originally pull, we have 52 cards to choose from. So choosing a black card is half of them are black, so that would be 26 over 52. But I don't put it back. So the next time I have 51 cards to choose from, and the chances of picking another black card, I've already picked 1, so that's going to be 25 out of 51, and I don't add these, I multiply. So the reason for this is if I have 2 cards that I'm choosing without replacement, so I have the probability of A times the probability of B. If I have 1 card, then it's the probability of A plus the probability of B. So it's a little tricky. Just keep that in mind. But 26 times 25 is, I can reduce the 26 over 25, and that's going to be 1 over 2. And so that's going to be 25 over 102. All right, if you dealt 2 cards successfully with replacement of the first from a 52 card deck, find the probability of getting a heart on the first card and a diamond on the second card. Okay, so again, we're multiplying. The chance of getting a heart on the first one is 13 out of 52. And if I put it back, the chances are the same. 13 out of 52 that I get a diamond on the second one. All right, I can reduce these. That's going to be 1 over 4. This is going to be 1 over 4. And so when I multiply that together, that's going to be 1 out of 16. A card is drawn from a well-shuffled deck. What is the probability of drawing an ace or a 7? All right, because it could be either or. I'm going to say plus. I'm going to add up my fractions. So an ace, there are 4 of them. There are also 4 sevens. So I got 4 out of 52 plus 4 out of 52. And that's going to give me 8 out of 52, which reduces to 2 over 13. All right. 2 dice are rolled. Find the probability that the score on the dice is no more than 6. Okay, well, that gives me two dice to roll. So 2, 4. Sorry, so the sum is 2, 3, 4, 5, 6. And I can't go any higher. So using the chart above, we found the probability of getting a sum of 2, 3, 4, 5, and 6. Added them all up. We got 15 over 36. And we reduced it to 5 over 12. Okay. A spinner has a region has regions numbered 1 through 21. What is the probability that the spinner will stop on an even number or a multiple of 3? Okay, so the even numbers would be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Multiples of 3 would be 3, 6, 9, 12, 15, 18, and 21. Now, there are some overlaps. So 6 overlaps, 12 overlaps, 18 overlaps. So one way to do this is to only write each number once, or the chances of getting an even number. Let's see, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can get 10 out of 21 for an even number. I have 1, 2, 3, 4, 5, 6, 7 that are divided by 3, or multiples of 3. But then I have some overlaps. How many overlap? 6, 12, and 18. That's 3 of them. So I could subtract 3 over 21, and that would get rid of the overlaps. Okay, so 10 plus 7 is 17. Minus 3 would be 14. 14 over 21. Reduce that, and you get 2 over 3. 7 goes into both of those, so 2/3. Okay, so what I just did was the probability of getting an even number plus the probability of getting a multiple of 3 minus the probability of the overlap. Okay. All right. Last problem. A bag contains 5 red marbles, 4 blue marbles, 1 green marble. What is the probability of choosing a marble that is not blue? Okay, so 5, 4, and 1, that's 10. All right, 4 of them are blue. So choosing one that's not blue is going to be 6 out of 10, which reduces 3 over 5. So you have 3 out of 5 chance to get one that's not blue. All right? So that is probability in a nutshell. Reach out if you have any questions, and I'll see you in the next lesson.